Welcome back, everybody. In this video, we're going to be taking our next look at the VPN topics, where we're going to focus or shift our focus from simple point-to-point tunnels like we've already demonstrated with pre-shared keys and things like that. We're actually going to flip it over to start taking a look at DMVPN, or Dynamic Multi-Point VPN. So I'm going to walk you through some of the logic pieces that you need to understand in terms of how it operates and things like that. And I'll continue using the Ink2Go application to help draw out and paint some pictures for you guys so you guys understand what's happening and things like that. We're going to break this down into multiple individual sections. So we're going to focus on taking a look at DMVPN as an overview. We're not going to actually go through the implementation of DMVPN. We're just going to talk about how it works and some of the things that you need to be aware of it. And then we're going to have several individual videos that cover, phase 1, phase 2, phase 3, multiple routing protocols, and stuff like that, so that it's easy for you guys to follow and understand. Because DMVPN, if you've never dealt with it before, it'd be kind of a learning curve for those of you that are familiar with point-to-point VPN technology solutions, like whether it's GRE over IPsec, SVTI, so on and so forth. So that's what we're going to be dealing with. So out of the gate, DMVPN is, like I mentioned, is Dynamic Multi-Point VPN. So what this allows us to do is dynamically peer over any type of transport. So what that means is I can simply have connections where, and I'll just use red for control plane because that's what we're going to be focusing on initially. It allows us to have peers dynamically discover each other, but unlike other mechanisms like the static GRE, where it would just be a connection like this back and forth, NHRP is used. Now then, I'm going to talk about NHRP in a little bit more detail later on, because we'll definitely need to understand how NHRP works and all that type of stuff, but we need to understand how DMVPN comes into play. So DMVPN uses a technique known as multi-point GRE, or MGRE. So, like I just drew out a moment ago, normally when you have a connection between two devices, so CSR2 and CSR4, for example, you're going to have a tunnel going, it's going to be a bidirectional tunnel, right? But it's going to be point-to-point. So if, for example, if CSR2 wanted to set up peerings to CSR4, 5, and 6, there would have to be connections to all of those guys, right? It would have to be set up like so, and it would definitely work, but you'd have 3 separate subnets. Each one of these would be likely a /30 prefix. You'd have connections going back and forth. All of that would work, right? Well, MGRE with DMVPN works a little bit differently. So let's go ahead and draw an ellipse first, because instead of doing point-to-point GRE tunnels, several /30 subnets connecting each and every one of the spoke sites to the hub, we're going to have a single cloud. So I don't have a cloud diagram to show you, or else I would use it. So the circle is going to represent all the nodes being on a common subnet. So that means we're going to have a connection from CSR2 to this connection here. CSR4 is going to connect in, CSR5 is going to connect in, and CSR6 is going to connect in. All of these nodes are going to have an IP address inside of the same subnet. So if we had, let's say for instance, the 10.1.100.0/24 prefix, if that was the prefix that we were going to assign to DMVPN for connecting CSR2 to CSR4, 5, and 6, then what we would do is that every one of those nodes, we would give each node an IP address inside of that prefix. So for example, CSR2 would be 10.1.100.2, CSR4 would be .4, CSR5.5, CSR6.6, so on and so forth. Now that works out really well, but that leaves some things to be desired. So one of the first things that we need to talk about is going to be we'll be leveraging a technique or technology known as Next Hop Resolution Protocol, or NHRP. And NHRP is how DMVPN really works under the hood. Now, DMVPN replaces the legacy connection where you have all of these GRE tunnels set up on these devices over and over and over again, like so. So the three lines that I just drew, they get erased and get removed in favor of a single tunnel that all of the nodes join and connect to. This allows dynamically created tunnels to be formed. So there's always going to be a tunnel that's configured from the spoke to the hub that's going to be considered to be always on or statically set up. And then the hub is going to dynamically learn all of the spoke connections to it dynamically through NHRP. Now, down the road, we're not going to talk about this in a ton of detail right now, but dynamic spoke-to-spoke communication is possible, but that will come into play later on down the road. We'll definitely get into that in Phase 2 and Phase 3 and how that comes into play. We'll take a look at a variety of different scenarios that would come into play with, but spoke-to-spoke communication is possible. Now, NHRP itself is the next top resolution protocol, and its job is basically to build GRE tunnels. And what it does is it's going to bind the public address to the private address. So the private address is going to be anything that is RFC 1918. So it's going to be something that you would configure on the tunnel interface itself. So interface tunnel 100, for example, you would give that IP address 10.1.100.x, 245, 74, 88, 197, so on and so forth. That's going to be considered to be your VPN address or your overlay. So if we were to break this up into slightly different terms, let's draw the underlay out real quick. So we're going to grab a line and we're going to change the color to be yellow-green. So we're going to draw a connection down to CSR1, and then we're going to draw connections from CSR1 to 4, 5 to 1, and then 1 to 6. So the green lines are going to be the underlay. This is all going to be public addressing. This is going to be what we refer to as the transport or the underlay. The key thing here we need to understand is green in this particular case indicates public addressing, transport information that it's going to be anybody can reach and connect to. So that's going to be the underlay. This is going to be the hop by hop by hop by hop connectivity between our endpoints. The red line, the red connections, is going to be the overlay. This is going to be the connections from the on the tunnel interfaces itself that are all in the same subnet that are connecting to all these nodes together. So we have the NBMA, which is going to be the public addressing, and we have the VPN addressing, which is going to be the private addressing. NHRP is designed to help map the NBMA to the VPN. That's its job. Just like you would see in ARP, you are going to know the IP address of a particular node on a network, more than likely inside of the same subnet you're in. But what's going to end up happening is you're going to have ARP come into play to help resolve the MAC address, especially if you're dealing with any type of layer 2 connectivity where you're going over Ethernet as your medium. So because Ethernet relies on MAC addresses to figure out the back and forth information, you're going to need to have the connectivity going back and forth. The switch is going to need to know what MAC address exists on which particular ports and how to intelligently forward that traffic. That's a layer 2 to layer 3 binding. NHRP is a layer 3 to layer 3 binding. You need to bind the public IP to the private IP so that NHRP knows what's going on and all that type of stuff. So what will end up happening is on the configuration side of the house for NHRP, you're going to still, for the tunnel interface, you're still going to set a tunnel source. So for example, CSR2 would set its tunnel source to gig 1. And so would CSR4, 5, and 6. They'd all set their tunnel source to be gig 1 so that they would know which public IP address to reference. What will end up happening then is the hub would be configured with the command IP NHRP map multicast dynamic. That's going to allow the communication from the hubs, or I'm sorry, from the spokes to be received by the spokes, sorry, let's rewind that a little bit. That's going to allow the spokes to point themselves to the hub, and when that traffic is being sent out from the spoke to the hub receives that and then is going to be able to dynamically build the NBMA to VPN addressing. So basically what will end up happening is CSR2 will know in order to reach the tunnel interface of CSR4 of 10.1.100.4, we need to go to the public IP address of 41.0.0.4. So there's a private to public mapping. So we need to know how to get the traffic from where I'm at to where I need to go through the underlay or the green lines, so that we know how to get there via the public transport, so we know how to route the overlay traffic via the red lines over DMVPN, over the tunnel. Now, the NHRP messages are encapsulated inside of GRE, so what's going to end up happening is from the spokes to the hubs, we're going to have statically built spoke to hub, point to point GRE tunnels. At a later point in time, we will be able to build dynamic hub to spoke and spoke to spoke, point to point GRE tunnels at a later date. That'll be come into play when we get into the phase 2 and phase 3 configurations. So there will be some messages that, there's a couple messages that we need to understand in terms of how it all comes into play. There's going to be a registration message, and I'm going to switch the color back over to, go to yellow for the time being. There's going to be a registration message that is going to be sent from the spoke to the hub. I need to point the arrow in the right direction. The yellow line indicates the registration message. Once the registration message has been received, the hub is going to send a message back to the spoke indicating that it has acknowledged the registration of the spoke and the tunnel was brought up. This is normally the point in time when you have you create a tunnel interface configuration for DMVPN on a spoke. You get it all squared away. The hub detects that, and then the tunnel comes online. So if you were to check the hub side, you would see a dynamically learned NHRP spoke, or I should say DMVPN spoke, through NHRP messaging. You would see that tunnel come up. You would see that peering show up in the DMVPN database. If you were to take that config and copy and paste it into another router by changing the tunnel source, so you would specify the IP address would change because the IP address on the NBMA interface would be different. But if you didn't change the tunnel interface IP, let's say we went from CSR4 to CSR5, and on CSR4 we're going to be 10.1.100.4. On CSR5 we're going to be 10.1.100.5. What will end up happening is if we were just to copy and paste it verbatim and not change the IP address, we'd actually get a kickback from the hub and say, you know what, that particular IP address is already registered to me. So something would need to happen. Either configuration needs to be modified or a cache needs to be flushed, something along those lines. So just make sure that you're changing your IP addresses on your tunnels on a per spoke basis to be a different IP address so you don't get registration errors. There's a couple of other ones that are going to come into play where we have the NHRP resolution request and resolution reply. This is going to be for when we want to form spoke-to-spoke connectivity. That's going to come a little bit later on down the line for us, but for right now, that's just an example of how that would come into play. And we have the NHRP redirect. The redirect is going to be a phase 3 specific configuration where if CSR6 wants to talk to CSR4, let's go this way instead, what will end up happening is there will be a message sent from CSR6 to CSR2 saying, hey, I want to send traffic to CSR4. What will end up happening is CSR2 will send a redirect message down to CSR4 saying, hey, somebody wants to talk to you directly. There would be a message sent back from CSR4 back to CSR2, and then from CSR2 down to CSR6, that message would be redirected so that CSR6 would be told you need to point towards the public address or the NBMA address of CSR4. So then what would end up happening is we would have a connection sent from CSR6 out to CSR4, and then eventually CSR4 and CSR6 would be able to communicate with each other, and all of that would be good. That's just an example of how phase spoke-to-spoke connections will come online. Now, there are a couple of different things that we could talk about in terms of communication and stuff like that. It's a good idea when it comes to doing routing over DMVPN, because what's interesting about DMVPN itself, its job, DMVPN is just a wrapper for NHRP. NHRP is doing all the real legwork here. What needs to be understood is unless NHRP is squared away, nothing else is going to work. So in order for DMVPN to work the way that it needs to, you need to have something in play like NHRP in order to build all the connections between the spokes and the hubs and potentially spoke-to-spoke communication. Now, typically speaking, IGP and BGP are going to be needed. So, not at the same time. You could use BGP in the underlay and IGP in the overlay, or a combination of both. We're going to be taking a look at a couple of different variations of this in order to work. You can also do static routing if you'd like, things like that. Now, the way that the connectivity from the spoke to hub works, I'm just going to spend a little bit more time on this specifically because we're going to be talking about DMVPN Phase 1 next in the upcoming video, where we actually go to set all this stuff up. But what's going to end up happening is the connectivity that we're going to have for the devices we're going to have is going to be client to server. So we are, in order for these connections to come online, it's going to be client to server is going to be the registration. So the clients will be configured with the server information, and it's going to point its NHRP messages to the hub. The hub will then respond to the client to let it know that everything's working the way that it needs to be. Once that's complete, then DMVPN has done all the things that it needs to do at that point in order to achieve basic functionality. There's a number of other characteristics that will be talked about as we progress forward. So I don't want to get any more deep into how DMVPN works overall. We're going to walk ourselves step by step through the config. But, pardon me. So the main thing that I want you guys to understand is that the clients will register with the hub, and this will be done dynamically. Once that process has been done, we'll then be able to we'll be able to add in routing over that. So we're going to take a look at a couple of different routing protocols, mainly EIGRP and BGP, because they work the best over DMVPN, but it is possible to use any routing protocol over DMVPN. They're all supported. You just have to be cognizant of their per hub and spoke design, or hub and spoke specific design issues. Like OSPF, you'd have to make sure that the hub is a designated router, or use a different specific or different network type. I find point-to-point and point-to-multipoint work the best. So that's just an example of how that will come into play. You can use whatever mechanisms you want, but I recommend not getting too far in the fray and just focusing on the ones that you need to worry about, which is EIGRP and BGP. I would definitely recommend doing OSPF a little bit just to see how it works and stuff like that, but you're also going to need to understand how they work independently of each other. So how does configuration for EIGRP work, OSPF, BGP, etc. on a per phase basis, so that you're not like, well, why is this not working? So you'll be able to see all of that as it goes along. And we're going to talk about specific design use cases, why you would use why you wouldn't use phase 3 in some designs, and why you would use phase 1 in others, and so on and so forth. So that's going to be the core competencies that I want you to understand in this video. And then in the following videos, we're going to take a deeper dive look at DMVPN and how all of that comes into play. So until next time, guys, thanks so much for stopping by and hanging out with me in this video. And until next time, take it easy.